Alright, this is your video for 8.4. It's over angles of elevation and depression. So once we learn what these are, then it's just regular trig, just applications of trig. So an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. And an angle of depression is an angle formed by a horizontal line and a line of sight to a point below the line. So that doesn't make sense too much, but let's look at this picture. So here you have a pilot and a guy in a control tower, and they are looking at each other. So this is what it means by the line of sight. So if you pretend like you're the pilot, he should be looking straight out, like he's flying straight out in the space ahead of him, but instead he looks down to be able to see the pilot, the guy in the little control tower. So this is an angle of depression. How much does he have to look down in order to see that guy? And then conversely, if you look at it from the guy in the flight tower a little from his perspective, he should be looking straight ahead, but how much does he have to look up in order to see the pilot flying in the sky? So depression if you look down, elevation if you look up. And since horizontal lines are always parallel, angle 1 and angle 2, or an angle of depression and an angle of elevation, will always be congruent because they're alternate interior. Let's flip back in this picture and see if you see that. So these are parallel. Here's your parallel lines cut by a transversal alternate interior angle. So they're always going to be congruent. However much the pilot has to look down is how much the control tower guy has to look up. So let's look at this picture here, and all we're doing is classifying. So angle 1, if you look from the horizontal, you have to go down to get to the line of sight, so that is an angle of depression. Angle 2, here's the horizontal, you have to go up to get to the line of sight, so that's an angle of elevation. Angle 3, from the horizontal you look down, so that is an angle of depression. And angle 4, from the horizontal you have to look up, so that's an angle of elevation. So there's 4 good examples. Okay, so now let's see how this applies to our trig that we've been doing for the last several days. The Seattle Space Needle casts a 67-meter shadow. So this right here is the Space Needle. I draw awesome. And he casts a 67-meter shadow. So this is the shadow right here. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70, so you have to label this yourself. So the shadow's down here, the top of the Space Needle is up here, so this would be your angle of elevation because it's from the horizontal up to the line of sight. So the most difficult part is getting that all labeled, and once you do, now this is just a regular trig problem that we've been doing for the last week or so. Okay, so let's label. We're trying to figure out how tall the Space Needle is, so that is the opposite side, and this is the adjacent side. So that means I'm going to do tangent. So tangent of 70 equals opposite over adjacent. This would be a multiply problem. So I'm just going to type 67 times the tangent of 70. And it is 184 meters tall. Okay, so once you get the picture labeled from the paragraph, none of this is new. The actual math and the trig is exactly what we've been doing since 8.2. Example 3. An ice climber stands at the edge of a crevice that is 115 feet wide. So first let's draw this picture. I'm going to zoom out just a hair. Okay, so here's your ice climber. And here is going to be basically your big hole for your crevice. And here at the bottom, that is going to be 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. So she would be looking straight out over but instead she's looking down to the bottom corner, and the angle of depression is 52 degrees right here. Okay, so this is the new stuff, is being able to read this paragraph and make your own picture. So make sure that this makes sense to you, 115, and that this is the 52. Okay, so now we know two things. You can do this one of two ways. You can either say, hey, this whole angle right here has to be 90, so you can do complementary. Or even easier than that, you can say what we just learned, well, if this is 52, then this has to be 52, because an angle of depression and an angle of elevation will always be equal. And that's the way I would go at it. So here's your triangle right here. And it wants to know how deep, so it wants to know how is the height right here. So according to the 52, this is the opposite side. This is the adjacent side, so we're looking at tangent again. Tangent of 52 equals opposite over adjacent. Multiply. So x is equal to 115, 115 times the tangent of 52, and that would be 147 feet deep. Okay? Alright, example 4. This is where it gets a little bit more difficult, just a hair. The observer in a lighthouse is 69 feet above the water. Okay, so here we are in our lighthouse. Okay. And the height of the lighthouse. This doesn't really work with my picture. There we go. Above the water. He sights 2 boats in the water directly in front of him. So let's make 2 boats. The angle of depression to the nearest boat is 48 degrees. So let's draw our horizontal. Here to the nearest boat, the angle of depression is 48 degrees. Whoops. The angle of depression to the other boat is 22 degrees. So these kind of overlap a little bit, and you have to be okay with that. Because I don't have to look down as far to see the further one out, but I have to look down that far plus some more to be able to see. So this one's the whole angle of depression, and this one is just part of it. Now the question is, what is the distance between the 2 boats? So what they're really asking me for is this distance right here. But what you can see is this is not a right triangle right here, so I am not allowed to do trig with it. I am going to have to treat this as 2 separate problems, and it's kind of hard to see with all the pictures. But I'm going to have to do it with this one, with the closer boat, and figure out how far this distance is from the closer boat to the lighthouse. Let's call that x. Then I'm going to have to recreate the whole problem and figure out how far is the further boat the whole way. We'll call that y, and then I can subtract them. There's no way I can just find the distance between the 2 boats at the same time. Seems I took up all my room with my awesome drawing. Alright, so let's look at this one right here. So if this is 48, I'm going to zoom in on these pictures. If this is 48, then this is 48. The lighthouse height is opposite, and we are looking for the length in the water, so that would be adjacent. So I'm going to say the tangent of 48 equals 69 over x. So this would be a switch and divide problem. X equals 69 over the tangent of 48. So let's type that in. So the closer boat is 62.13 feet. And we want to keep a couple of decimals until we're all the way done at the end of the problem, then we can round. Same story for the second one. If this is 22, this is 22. The height of the lighthouse is opposite. We're looking for adjacent, so it should be the same setup. Sub in 22 wherever you see the 48. Okay, so y is equal to 6/9 over tangent of 2, 2. So this one is 170.78 feet away. And then you can say, okay, if the further one is 170 feet away and the closer one is 62 feet from the lighthouse, then, 0.13, then they are 108.65 feet apart. And now that we're done with the question, now we can round. So we can close this problem out by saying they are 109 feet apart. So let me show you this again on the big picture. So if the closer boat is 62.13 feet away, the further boat is 170.68 feet away, then we can subtract and get 109. Okay, pause here and try to check it out. The last example, it is exactly like this problem right here. Same setup, same solving, same everything. So try it out for yourself. So for the closer airport, I did tangent of 78 equals 12,000. 12,000 over x. Switch and divide, and you get the closer airport is about 2,500 feet away. Same story for the other one, except for the altitude, or the angle of depression rather, is 19 degrees. So when I do the same setup with 19 degrees, I get this further airport is almost 35,000. So then my question though is not how far away is the plane from the airport, it's how far away are the two airports. So then I can just subtract my two previous answers to realize that the airports are approximately 32,300 feet away. Okay, see you tomorrow.